Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0498, indicates a low voltage condition in the EVAP Canister vent shut valve circuit of the Honda CRV between the model years 2017 and 2022. This code directly impacts the evaporation EVAP system, which is responsible for capturing and recycling fuel vapors from the fuel tank to prevent them from escaping into the atmosphere. The EVAP canister vent shut valve plays a critical role in this system by ensuring that the canister is sealed when necessary, preventing vapor loss during normal operation and maintaining optimal pressure in the fuel system. This valve is typically located near the EVAP canister, which is often positioned in the rear of the vehicle near the fuel tank. The presence of this DTC can lead to increased emissions and potential fuel system performance issues if not addressed promptly, resulting in more significant engine inefficiencies. Therefore, accurate diagnosis and repair of this low voltage condition are crucial for the vehicle's environmental compliance, performance, and reliability. The EVAP system is integral to the vehicle's emissions control strategy. It captures and recycles fuel vapors, reducing harmful emissions that contribute to air pollution. At the heart of this system is the EVAP canister vent shut valve, which operates by opening and closing to control vapor flow from the canister to the engine during certain operating conditions. Located near the EVAP canister, typically beneath the rear of the vehicle, the vent shut valve also connects to the vehicle's powertrain control module, PCM, which manages its operation. This valve is a solenoid-type device that reacts to changes in engine load and pressure to maintain proper function. Any issues, such as low voltage, disrupt its operation and trigger the P0498 code, indicating a malfunction in this critical component. There are several possible causes for the P0498 code. First, a damaged wiring harness can lead to intermittent connections or shorts, causing low voltage readings in the EVAP canister vent shut valve circuit. Secondly, if the vent shut valve itself is faulty, it may not respond correctly to PCM commands, resulting in low voltage conditions. Another potential cause is a malfunctioning PCM, which may fail to send the correct voltage signals to the vent valve. Such issues can arise from environmental factors, age-related wear, or manufacturing defects. Properly identifying and remedying these causes is essential to restore the integrity of the EVAP system and ensure compliance with emission standards. When the P0498 code appears, several symptoms may manifest. The most immediate is an illuminated check engine light, which alerts the driver to potential internal issues within the vehicle's systems. Additionally, the vehicle may experience poor fuel efficiency, as the malfunctioning EVAP system can lead to incorrect fuel vapor management, potentially causing the engine to work harder. Increased emissions can also occur due to improper handling of fuel vapors, leading the vehicle to fail emissions testing. Lastly, drivability issues may arise since the engine control unit may modify fuel dosage or timing, affecting smooth operation. Observing these symptoms emphasizes the need for timely diagnosis and repair. The first step in troubleshooting DTC P0498 involves following a systematic approach to identify the issue accurately. Begin by turning the vehicle to the on mode without starting the engine. This is critical as it powers the vehicle's systems and allows the Diagnostic Healthcare Software, HDS, to communicate with the onboard computers. Next, clear the DTC using the HDS, which resets the fault codes and prepares the system for re-examination. After clearing the codes, start the engine and allow it to idle in either park or neutral for a minimum of 5 seconds. This idling condition enables the vehicle's control systems to perform self-checks and can potentially reveal whether the DTC reappears, indicating a persistent issue. In the second step, it is vital to verify the problem further using specialized testing through the HDS. Select the EVAP test function within the inspection menu on the HDS. This test enables targeted analysis of the EVAP system components. Execute the EVAP CVS on test in the single solenoid, which specifically checks the function of the canister vent shut valve. After conducting this test, check again for any pending or confirmed DTCs with the HDS. This additional data will help determine if DTC P0498 continues to be indicated, thereby confirming the original diagnostic detection or revealing any intermittent failures. If the DTC persists, the issue is likely active and troubleshooting should progress to the next step. Proceeding to step 3, first switch the vehicle to the off or lock mode. This step ensures that no electrical current is running through the system while testing. Next, disconnect the EVAP canister vent shut valve 2P connector, which allows for direct measurement of voltage without interference from the rest of the system. Subsequent to this, turn the vehicle back to the on mode, preparing to take voltage measurements. Use a multimeter to measure the voltage between test points specified, the non-fuse side of the connector, and a body ground. If you find battery voltage present at this step, this suggests that the wiring for the IGPS LAF line is functioning correctly, allowing you to move on to the next troubleshooting step. If not, it confirms an open circuit exists that requires immediate attention. Step 4 requires you to revert to the off or lock mode of the vehicle again. With the EVAP canister vent shut valve 2P connector disconnected, measure the resistance across the specified terminals of the valve. Using a multimeter, test the resistance between the two male terminals of the vent shut valve connector. At room temperature, you should anticipate a resistance reading between approximately 25 to 30 ohms. This resistance value is essential. If you obtain a reading within this range, it indicates that the vent shut valve is operational and functioning correctly. Conversely, a significantly higher or lower reading signifies that the valve may be defective, and replacement would be necessary to restore proper functionality. Accurate resistance measurement ensures that the component integrity is confirmed before moving on to further checks. Moving forward to step 5. Start by ensuring that the vehicle is in the off or lock mode. Then, use the HDS to jump the SCS line, allowing the technician to bypass certain modes to facilitate the following tests. After this preparation, it is crucial to disconnect the PCM connector A, which is typically a 51-pin connector. Now, check the continuity between the designated test points, focusing on the wire's condition leading to the body ground. This step aims to verify any shorts present in the variable saline valve, VSV, line between the PCM and the EVAP canister vent shut valve. If continuity is established, it indicates a short circuit situation that requires repair, whereas its absence demonstrates that the wire is intact, leading you to the next set of diagnostic steps. In the final troubleshooting step, reconnect the terminals A and B using a jumper wire to facilitate the next continuity test. Terminal A refers to the female terminal of the EVAP canister vent shut valve connector, while terminal B should connect to a secure body ground. With this configuration, you will again check for continuity between the respective test points. The condition of the wiring should be verified once more to ensure that no open circuits exist between the PCM and the vent shut valve. If continuity is confirmed, then the VSV wire and its connections are functioning correctly, redirecting the approach towards validating the PCM's performance or consulting authorized service information for further troubleshooting. If continuity is absent, repairs must be made to address the open circuit status, ensuring that the wiring integrity is thoroughly restored to resume normal EVAP system operation. Upon completing all necessary repairs, you should conduct a final verification to ensure the problem has been resolved. Begin by clearing the Diagnostic Trouble Codes, DTC, using the HDS again. This reset allows the monitoring systems to refresh and begin a new operation cycle, free from past errors. After clearing the DTCs, it's essential to perform a test drive of the vehicle under various conditions. Monitor the vehicle's performance during this test drive, while paying particular attention to the dashboard displays for any illumination of warning lights. Ensure that no new DTCs appear during this monitoring phase, as this indicates that the repairs were successful and the EVAP system functions as intended. Confirming the absence of DTCs revalidates that the issue has been effectively addressed. To prevent the recurrence of DTC P0498 and ensure the longevity of the EVAP system, regular maintenance is critical. Regularly inspect the wiring connected to the EVAP canister vent shut valve and its related components for any signs of wear, damage, or disconnection. It's also advisable to check connectors for corrosion, as moisture can lead to poor electrical connections and faults in the system's operation. Additionally, periodically monitor the overall performance of the EVAP system during routine vehicle checks or emissions testing. By maintaining an organized schedule of inspections and servicing, you can help avert potential issues before they lead to serious mechanical failures or expensive repairs, thereby extending the life of your vehicle's components. In conclusion, the P0498 code points to a low voltage condition impacting the EVAP canister vent shut valve circuit within Honda CRV models from 2017 to 2022. Through understanding the role of the EVAP system and its components, we can appreciate the importance of accurate troubleshooting. Each step, from simple diagnostics to complex wire checks and resistance measurements, provides critical insights into the nature of the issue at hand. It's imperative to follow a systematic approach when addressing this DTC to effectively isolate and rectify the underlying problems. Lastly, engaging in preventative maintenance can significantly minimize the risk of future occurrences and promote reliable vehicle performance. Timely and thorough attention to this issue can ensure compliance with emission standards and improve overall vehicle efficiency. Please like and subscribe to the channel. See you next time.